Easy Pieces. Written by Richard Feynman. Introduction. Understanding the foundations of physics.
Physics is often perceived as a complex and intimidating subject, filled with intricate equations and abstract theories. Yet, at its core, it is the study of nature, the rules governing the universe, and the fundamental forces that shape reality. 6 Easy Pieces offers a gateway into this world, presenting essential concepts in physics through the eyes of one of the greatest scientific communicators of the 20th century, Richard Feynman. Rather than drowning in mathematical formalism, this book distills physics into its most fundamental ideas, making them accessible without sacrificing depth, covering topics such as atomic theory, the laws of motion, energy conservation, and quantum mechanics. Feynman breaks down these principles with clarity, wit, and a deep passion for the subject. His approach is not just about explaining science, it's about inspiring curiosity, encouraging critical thinking, and revealing the beauty of the natural world. This book summary explores the 6 key lectures that form the foundation of modern physics, revealing not just the principles themselves, but also the elegance and wonder behind them.
Atoms, the building blocks of matter.
Everything in the universe, stars, water, air, even the human body, is composed of tiny, indivisible particles called atoms. This idea, central to all of physics, explains the diversity of materials and the nature of chemical reactions. Atoms are incredibly small, yet their behavior determines the properties of everything around us. They are in constant motion, vibrating in solids, flowing in liquids, and dispersing in gases. Even in seemingly static objects, atoms never rest. This movement is responsible for fundamental phenomena such as heat, pressure, and diffusion. One of the most striking insights about atoms is how few types exist, yet they create endless complexity. With just around 100 elements, the entire universe is built. The way atoms combine into molecules determines whether a substance is water, iron, or DNA. This simple yet powerful concept forms the foundation of chemistry and biology, showing how physics governs the natural world. Additionally, atomic theory explains why materials behave differently. Metals conduct electricity because their atoms allow free movement of electrons, while rubber insulates because its atomic structure restricts electron flow. These principles underpin countless technologies, from electrical circuits to medical imaging.
Basic physics, the rules of nature.
Physics is often described as the most fundamental science because it explains the rules that govern everything else. Whether studying electricity, gravity, or the behavior of gases, the principles remain consistent. One of the most important laws in physics is the principle of conservation, the idea that certain properties like energy and momentum remain constant in a closed system. This means that energy cannot be created or destroyed, only transformed. A swinging pendulum, for example, continuously converts energy between motion and height, but the total energy stays the same. Another core idea is Newton's laws of motion, which describe how objects behave. The first law states that objects remain in their state of motion unless acted upon by an external force. This explains why astronauts in space, free from friction, keep floating indefinitely. The second law relates force, mass, and acceleration, forming the basis for engineering and mechanics. The third law, every action has an equal and opposite reaction, explains everything from rocket launches to the simple act of walking. These principles are not just theoretical. They govern every aspect of life, from how cars function to how planets orbit the sun.
The relationship between physics and other sciences.
Physics is deeply connected to all other sciences. Chemistry, for example, is simply the study of how atoms interact, which itself follows the rules of physics. Biology, though complex, is ultimately governed by the same fundamental principles. Take temperature, for instance. It is often thought of as a property of objects, but in reality, it is just the measurement of how fast atoms are moving. The heat in a cup of coffee, the weather outside, and the metabolic processes in the human body all follow the same principles of thermodynamics. Even psychology and neuroscience, which study the human mind, are linked to physics. The way neurons fire in the brain is based on electrical impulses, which are governed by the laws of electromagnetism. This interconnectedness extends to engineering, medicine, and environmental science. Advances in physics lead to medical breakthroughs, from MRI scans to laser surgeries. Even climate science relies on physics to model global temperature changes and predict weather patterns. By understanding physics, one gains insight into the mechanics of the entire universe, from the smallest particles to the largest galaxies.
Energy conservation, the universe's balancing act.
One of the most powerful ideas in physics is the conservation of energy. No matter what happens, energy never disappears. It only changes form. Consider a bouncing ball. As it rises, its energy is stored as potential energy. As it falls, that energy converts into kinetic energy, the energy of motion. When it hits the ground, some of that energy turns into heat and sound. But the total energy remains the same. It just shifts between different forms. This principle applies on a cosmic scale as well. The energy from the sun that fuels life on Earth originates from nuclear reactions, where mass itself is converted into energy, following Einstein's famous equation, E equals mc squared. Understanding energy conservation helps explain everything from how batteries work to the efficiency of machines. It also highlights why perpetual motion machines, devices that claim to run forever without an energy source, are impossible. The universe does not create energy from nothing. It simply redistributes what already exists.
Quantum mechanics, the strange world of the small.
At the atomic level, the laws of classical physics no longer apply. Instead, the universe operates under the bizarre rules of quantum mechanics, where particles can exist in multiple places at once, behave both as waves and particles, and change their state simply by being observed. One of the most famous quantum phenomena is the double-slit experiment. When electrons are fired through two slits, they create an interference pattern, behaving like waves. But when observed, they behave like particles, as if aware of being watched. This challenges the traditional notion of reality, suggesting that at a fundamental level, nature does not behave in a fixed, predictable way. Another strange property is quantum entanglement, where two particles become instantaneously connected, no matter how far apart they are. This spooky action at a distance, as Einstein called it, suggests that information can travel faster than light, defying conventional physics. Though counterintuitive, quantum mechanics is not just theoretical. It is the foundation of modern technology, including transistors, lasers, and quantum computing. Without it, much of today's digital world would not exist.
The atomic nucleus, the power within.
Deep inside atoms lies the nucleus, a tiny but incredibly dense region that holds protons and neutrons together. The forces operating at this level are among the strongest in the universe. When nuclei are split apart or fused together, enormous amounts of energy are released. This is the principle behind nuclear power and atomic bombs. The energy released from nuclear reactions comes from the conversion of mass into energy, as described by Einstein's equation. Understanding the nucleus has led to some of the greatest scientific advancements, from the development of nuclear energy to medical imaging technologies like MRI scans. It has also raised ethical questions about how humans harness this power, particularly in warfare.
Conclusion: the elegance of physics.
Physics is not just about numbers and equations. It is about understanding the fundamental nature of reality. The concepts explored in 6 Easy Pieces reveal a world governed by simple yet profound principles that explain everything from the movement of planets to the behavior of subatomic particles. This book summary captures the essence of Feynman's teachings, showing how physics connects to everyday life, other sciences, and the broader universe. The more one understands these principles, the more the world transforms from a collection of random occurrences into a beautifully structured system, governed by laws that are both mysterious and deeply elegant.